All right, looking at section 8 now, factoring polynomials completely. And the only thing that's really different about section 8 is that you're going to be given everything at once. You're going to have to try to factor things using all of our techniques, kind of all together. And see, they list here factoring by grouping, but we've actually already been doing that. Whenever we're factoring, like what we did in 42 in these two steps, that is factoring by grouping, or I guess you could say all three of those steps. That's factoring by grouping, so we should already be experts at that. So let's look and see what happens here. We have a polynomial with 4 terms. Whenever it has 4 terms, you want to check factoring by grouping. So the first 2 we underline, the second 2 we underline, and we're going to be trying to break apart like we did above. So I'll pull out an x squared, and I'm left with x plus 4. And then I'll pull out a 3, and I've got x plus 4. Now you should be able to recognize that these are the same things, so they can come out front, and then we're left with the leftovers, x squared plus 3. And that's it. Again, it's extremely similar to what we did at the end of last section and what we did in, what was the section before that? Very similar to what we did in 7.6. Very similar. All right, let's look at number 44 now. The first 2, we can pull out an x, and we're left with x plus y. The second 2, we can pull out a 7, and we've got x plus y again. The x plus y's are in common, so they can come out front. We can factor that out. And then we're left with an x plus 7. And that's that. All right, here's some guidelines to use, just some things to kind of keep in the back of your head. So whenever a problem just says to factor, right, now that we're putting everything together, you first want to look and see, is there something that I can pull out of everything? Is there a monomial? After that, they say to look for a difference of 2 squares or a perfect square trinomial. Now, I normally don't look for the perfect square trinomial piece of it, but the difference of 2 squares, I definitely do that. That would be like a squared minus b squared. I definitely look for that. And if that's not there, or maybe looking at it at the same time, really number 2 and 3 can kind of go to the same thing. You want to be looking for one that can factor like this. Okay, and that would be like the one that I was just showing above from, I don't know, a problem similar to number 42 here. Lastly, the textbook suggests that we factor by grouping. So they say that should be our last resort, and oftentimes it will be our last resort, okay? Factoring by grouping is only happening whenever we have 4 terms, okay? I know it happens kind of in the middle of factoring one like ax squared plus bx plus c, but we normally don't just outright start off factoring by grouping, right? We have to do some intermediary steps whenever we're factoring that. So factoring by grouping is when we have 4 terms. That's something good to remember. All right, 45. Looking at our rules, step number 1, or rule number 1, is to factor out the greatest monomial. And here we actually can do that. We see that all 3 pieces have an x, so we can pull out an x, and then also all 3 pieces are multiples of 5, so we can pull out a 5. That'll leave us with x squared plus 2x minus 4. Now that I've done that, I look and I say, well, what can I do now? Can I factor it anymore? And I think about, well, breaking apart this 4. And there's actually no factors of negative 4 that add up to be 2, right? There's just no way to do it, right? You'd have negative 2 and positive 2, negative 4 and positive 1, negative 1 and positive 4. None of those add up to be 2. So this one we're actually done. We've done all of our factoring, and this is our answer right there. Okay, this is one of the difficult pieces of this section, is that not only do you have to factor it, but you have to be able to recognize when you're done, right? This problem, we ended with a trinomial, which so far we haven't been given a trinomial that doesn't factor. So we're going to have to be able to check that and be able to recognize that in our problems. Let's look at next up. 46. We look for a common monomial, and we could pull out a 2 out of everything. 2, and then y squared minus 6y plus 9. And then I look for things that multiply to be 9 and add up to be negative 6. That's going to be negative 3 and negative 3. So now I'm breaking this apart. I'm going to have my 2 out front. And then it's going to break apart to be 2 negative 3. So I'm going to write this as y minus 3 squared. And that's going to be my answer. Next up, I look for things that can come out. Everything's a multiple of 5. And then I look, there's a lot of y's there. I can pull out a y cubed. So I'll be left with y squared minus y minus 2. Now I look for things that multiply to be negative 2 and add up to be negative 1. That's going to be 2 minus 1. Oop, wait, hold on. Negative 2 plus 1. There we go. So we'll have 5y cubed, y minus 2, y plus 1. And that'll be our answer. 48. This one has 4 terms, so we need to try to factor by grouping. The first ones I can pull out a p squared, and I'm left with 3p plus 5. And the second ones, I can pull out a negative 4. And the reason I'm doing it negative, right, is so that the pieces in the parentheses are end up being the same signs. So negative 12 divided by negative 4 gives me 3p. Negative 20 divided by negative 4 gives me a positive 5. And that leaves me with 3p plus 5, and then p squared minus 4. Now, I'm tempted to just circle this as my answer, but we're actually not done yet. This guy right here, that is a difference of 2 squares, right? 4 is 2 squared. So this can break apart once more to be 3p plus 5. And then the second piece is p plus 2, p minus 2. Now we're done, okay? So this trick often occurs whenever we have factoring by grouping. At the end of a factoring by grouping problem, you'll want to make sure that you don't have a difference of 2 squares, because that ends up popping in and it is often overlooked. So we want to, anytime we have a problem like 48, we want to make sure that we check for that at the end of the problem. All right, 49. Another difference 2 square, not difference 2 squares, another factor by grouping. So we're going to look at the first 2, second 2. We can pull out an m, and we're left with m plus 2. And the second one, we can pull out a 6p, and we're left with m plus 2. Then we have m plus 2 out front. And then our leftovers, m plus 6p. And there we go. Next up, example 50, and it's our last example. This one, we can pull out a 4y right away, 4y, and we're left with y squared minus, what is 36 divided by 4? Is that 9? I think that's 9. And then right here, kind of like in number 48, we want to look and we want to see that difference 2 squares. 9 is 3 squared. So this will now be 4y, y plus 3, y minus 3. Right? Again, this is a very easy mistake, is to not notice that that's the difference of 2 squares. Lots of people would stop and they would circle that. Or up here, they would stop and they would circle this. Okay, but you got to recognize that difference 2 squares. It's an easy mistake, so don't be making that mistake. All right, that is the end of chapter 7, and that's it.